Welcome to the Day 13 video solution manual for the We Are Ready series of ISTEP Prep videos. This particular video is a little bit different from most of the others in that it is once again wanting us to use the graphing utility. It's also different from the previous video that covered the graphing utility because the first two questions are linear and the second two questions are quadratic. So it will allow us to see how we use the quadratic graphing utility as well. So the first one is a line in slope-intercept form. Now again, if you don't remember how to get to this, you're going to go to the school's website under Students, Links, and Testing, which would take you to this page. You click on the Practice ISTEP link, which will take you to this page, and then you click on the ISTEP Grade 10 and hit Start, which will take you into the actual ISTEP10 experience. Now, once again, when we do this, we are not doing the problem that it shows. We don't care about that. Okay? We are being asked to graph the function y equals negative 1/4 x plus 7. Now this is a linear equation. We are going to start at the y-intercept of 0, 7, and then from there we are going to use a slope of negative 1/4 to tell us that we're supposed to go down 1 unit and right 4 units. So, once again, to graph a line, we click on the linear button, which will bring up this generic line. We will then move one of the points to 0, 7, our starting point, and move the other point from there down 1, right 4. This will generate a slope of negative 1/4 and give us our line correctly graphed. So let's grab an image of that and take it back over to the other page to put in our solution manual. So, edit, paste, there it is, and move it to where we can see the question. Okay, that's what that should look like. Next one here, we're going to graph this function, y minus 3. Let's get everything reset here. Okay, we're going to now graph the line y minus 3 equals 2 times x plus 4. This is in point slope form. So if we look, this is in the form y minus y1 equals m times x minus x1, which means y1 is 3, m is 2, x1 is negative 4. x1 and y1 always have the opposite signs of what's shown in the equation. Now what does that mean? Well, we're going to start at x1, y1, or negative 4, 3. And then just like we did for the other one, our slope, which could be written as the fraction 2 over 1, tells us that we're going to go up 2 and then right 1 unit. So, we are going to click linear to get the line on there. We're going to move one of those to negative 4, 3. And then from negative 4, 3, we're going to go up 2 and right 1. This will generate the correct line and give us the picture we're looking for. Okay, now that brings us to our first quadratic. So let's get reset here for the quadratic. All right, we are going to be graphing y equals x squared minus 8x plus 12. Now when we graph a quadratic function, we need to find what is called the axis of symmetry, which is the line x equals negative b over 2a. Now what I mean by a, b, and c, a is 1, b is negative 8 in this case, and c is 12. So, in this case, negative b would be positive 8 over 2 times a is 8 over 2, or 4. Now that axis of symmetry implies that we have the line of symmetry that passes right through the middle of our parabola located on the line x equals 4. So our parabola is centered on that line. Now that line obviously is not going to be on your graphing utility. But the other thing we know is that the vertex of this graph lies on that line. So we need to figure out what y is when x equals 4. So we're going to do direct substitution and plug 4 in for x, and then we're going to feed that to our calculator. That would be 16 minus 32 plus 12, or negative 4, which means that our vertex is located at the point 4, negative 4. Now, why is this important? This is important because when we click on the quadratic button, it's going to put a quadratic on the screen. And when we graph a quadratic on the ISTEP, we have to graph the vertex first. So we need to take the vertex point and move it to the point 4, negative 4. And I just noticed that my line, when I finished graphing it, moved over a unit. It should be right there. Notice that the parabola should be centered on that line. Now, parabolas have a very set pattern. When we go out 1, we go up a. So in this case, a is 1. So if we go out 1, up 1, and drop that second point, it's going to graph that for us. So this would be the correct picture for that, because our second point should be placed out 1 and up a units. In this case, a is 1. And again, the utility itself will do the graphing for us. Let's grab a picture of that and take it back to our solution manual here. And then we will graph that last parabola. So there's that parabola. Okay, so last but not least, we have been asked to graph another quadratic, y equals 2x squared plus 4x plus 5. So again, we need to identify that a is 2, b is 4. Not nearly as important, but it's worth noting that c is 5. So we need to find the vertex. So we start with the axis of symmetry. Again, that is the equation x equals negative b over 2a. That's part of the quadratic formula. So if you're not sure you can remember it, just remember it's on the page as part of the quadratic formula on the reference sheet. So in this case, that would be x equals negative 4 over 4, or negative 1. So then we need to know what y equals when x equals negative 1. So we plug in negative 1 for x. That would be 2 times 1 plus 4 times negative 1 plus 5, or 2 minus 4 plus 5, which would be 3. So our vertex is located at negative 1, 3. Okay, so we're going to click over here on quadratic and move our vertex, the bottom point here, to negative 1, 3. Now again, from there, we're going to go out 1 and then up a. So since a is positive 2, we go out 1 and up 2, drop that point, and that is our parabola. So there's our final picture there for the end of day 13. Only a couple of videos left, folks. I hope you're using them.